So solutions can be measured by the concentration of hydrogen ions, and so an acidic solution, when it's dissolved in water, it releases excess hydrogen ions. So you have an excess, you have more, like if it's a neutral solution, they have an equal amount of hydrogen and hydroxyl. But if you have a acidic solution, they have excess hydrogen, and basic solutions will release excess hydroxyl ions. And so they'll, that is, again, like we were talking about with electrolytes, they release ions into solution, and acidic solutions or acids will release hydrogen, and basic will release hydroxyl. And so their moles per liter, that is a term that's, they usually use the capital letter M to represent moles per liter. So moles is like a chemist's dozen. It's like a number of particles per liter. And so it's a constant, it's number of particles per liter is basically what we're saying there. And so this concentration, when it's neutral, they release an equal amount of sodium or hydrogen and hydroxide. And so that is neutral. But if you have a higher concentration of hydrogen, this is going to be acidic. So it's a smaller number. I mean, it's a larger number than down here. These are bigger numbers, so they have a higher concentration of hydrogen. But if you have a higher concentration of hydroxide, then that makes them basic. So higher concentration of hydroxide would be basic. And so the logarithm, that's really the base of 10, is going to give us a pH. So the negative log of the hydrogen ion concentration will give us our pH. So pH stands for parts hydrogen. So the P is parts or power, and H is representing the element hydrogen. And that is why the H is always capitalized. And so if you had a 0.001 molar hydrogen ion solution, this would be equal 1 times 10 to the negative 3 molar of hydrogen ion. And so the negative log of 1 times, we usually put brackets around, not parentheses, 1 times 10 to the negative 3, the log of a number is the power of 10. So the pH is equal to the negative log of 1 times 10 to the negative 3. So that'd be a negative of negative 3. And a negative times a negative is a positive, so the pH is just 3. So that is how you determine the pH of a solution. And so if you look at this chart here, like if they have a pH, if the concentration is 10 to the negative 9th, then the pH is the negative log of negative 9, so it'd be 9. And you're like, well, how does that work with the OH? Well, these two numbers have to add up to 14. So if your pH is 9, then the POH would be 5. So 5 and 9 equals 14. So the two exponents, like negative 4 and negative 10, have to add up to negative 14. So not that you are going to be tested on that part. You will be tested, though. You need to be able to determine like the pH if I give you the pH of a solution. And you need to know what it is. Is it basic or acidic? So acidic is going to be from 0 to 6.9, and basic is going to be 7.1 to 14. And then if you have 7, that is neutral, because at that point you have the same exact amount of hydrogens and hydroxyls. And by the way, this is the reason for that is that H2O, naturally pulls itself apart in itself. It naturally dissociates or ionizes into hydrogen and hydroxyl, an equal amount of that. And the rate at which it does this is 10 to the negative 7th molar of hydrogen. And if you have that and it's equal, it's going to be 10 to the negative 7th hydroxide. And so that is why. And so water is like 10 to the negative 14. But anyway, that's really not correct. But anyway, these two, that would be the concentration. If you have a balanced neutral solution, you have an equal amount of hydrogen ions and hydroxide ions. And so if you have more of hydrogen, then you're acidic. If you have more hydroxide, then you're basic. And so some examples like hydrochloric acid, lemon juice, vinegar, red wine, sauerkraut, beer, acid rain, cheese, those are all acidic. And they're kind of weakly acidic as they get closer here to 7. And they're weakly basic, but then as they go out further away, like potassium hydroxide, oven cleaner, lime water, these are all pretty strong. Ammonia, which is not on, oh yeah, household ammonia. Ammonia, NH4 is something we're going to see in as a product in biochemical tests, and it raises the pH, and you can see the household ammonia, what you use as a cleaner, is like 11.5. So it's a really very strong base, and if it's present, it usually pushes the pH past into the basic realm. So again, below 7 is acidic and above 7 is basic. A neutralization reaction would be where you have a strong acid and a strong base, and when they do this kind of exchange thing where hydrogen and sodium switch places, so then you have water, HOH is water, and then sodium and chlorine make sodium chloride. So that is the end of our section on inorganic chemistry, and that is basically section 1. So I'm going to go over a few questions here. We'll talk about carbon in the next unit, in the next section. So so here's our concept check for section 2.1. List and describe the 3 particles associated with atoms. What's the difference between a molecule and a compound? What's the pH of a solution with 0.001 molar hydrogen ions? And is a solution with pH of 3 neutral, acidic, or basic? So we'll go over those concept questions in the next video.